Okay, a little bit about the denaturation of enzymes. Denaturation just means changing away from its natural form. So this is what my enzymes will normally look like. Pretend they both look the same, okay? If I change the shape of my active site of my enzyme, it can no longer carry out its function. That's it. Do not pass go, do not collect 200 pounds. One thing that can affect the structure of proteins, because all enzymes are proteins, remember, is temperature. If I've got a very high temperature or a very low temperature, enzyme activity doesn't work. I'm going to draw a graph here. I'm going to show a general trend of the activity of enzymes with this particular environmental stimulus. What it looks like is this. There is a bell curve, all right, just like normal distribution. This says to me that enzymes have got their highest activity with a particular temperature. Okay, and in the human body, no prizes for guessing. That's about 37.5 degrees Celsius. Okay, this temperature up here at which my enzymes work the best is the optimum. At that temperature, my enzymes are happy, they do their job really well, and nobody's complaining. However, if I were to increase that temperature, this is my optimum temperature, and this is my optimum temperature, okay? If I was to increase that temperature, if I was to make it just a little bit warmer, by maybe 2 or 3 degrees Celsius, then my enzyme is going to change its shape. All right, the active site is going to change. This could be, here in my graph maybe. Now, it's still able to carry out its function. It's not 100% perfect, but it's still there. It's working quite well, but not as well as you'd like. So if you've got something like a fever, all your enzymes don't immediately stop working. They stop working as hard, they don't work as well, which is why you feel ill, but they don't start working straight away. Let's say I was to increase the temperature even more, then my active site is going to change even more. So this now, it's pretty useless. It's only working about half of the time, which isn't very good if you're trying to respire, or if you're trying to break down food, or if you're trying to send messages along nerves. My active site is no longer the right shape, so it won't be able to do its job as well. Eventually you get to a point where the temperature is so low that you have changed entirely what the enzyme looks like. Okay? So it can't do its job at all, no enzymes are going to work, no reaction is going to be carried out, that's it, end game. So if I increase my temperatures, if I increase my temperature, my enzyme shape is going to change, my enzymes are going to denature. However, it's not the same if you go cold. Okay? Cold temperature isn't going to change the shape of my active site. Again, pretend these are all the same. Okay? What happens as I decrease the temperature, I decrease the amount of energy that's in my cell. So if I decrease my temperature, I'm decreasing the amount of energy. Enzymes need energy to work. They need to be able to collide with their substrates, and if they can't do that, if they don't have the energy to do that, then the reactions can't carry out. So if I decrease my temperature ever so slightly, my enzymes will have a little bit of energy, but they won't be able to carry out their functions as they normally would. If I decrease my temperature exceptionally, then there'll be very, very little energy there for my enzyme to carry out its function. And if I get you down to somewhere where there's absolutely no temperature, like not the right temperature, 2 or 3 degrees Celsius, if your body is 2 or 3 degrees Celsius, then you've got no activity at all. Alright? So, to the right, as you increase your temperature, you're denaturing your enzymes. You're changing the shape of your active site. To the left, as you decrease energy, you're decreasing the amount of energy that is available for my enzymes to work, so you get their activity decreasing.